Thank you very much, Greg. I'd like to start by taking 10 seconds for you to stand up and stretch. You know, we've been sitting for a while, and this is longer than a university class. There was a rugby match last night. So those of you who think the right team won, remain standing. The rest of you sit down. Only one. They had one fan. Okay, thank you. Please, the rest of you sit down. So I'm in my third career. When I was a young man, I was a farmer, growing potatoes and sweet corn and peas and beans. And then I became a professor for more than 3 decades. And now I'm a consultant, and my main client is Simplot. But my background is simple. I come from a part of the country where we have a simple food pyramid. Many of us have German heritage, so there it's okay to say these foods in German. Bier, Bratwurst und Käse, ja wunderbar. What could be better? Well, they do tolerate some side dishes there, including some potatoes and vegetables. But this is a photo of the farm, a fourth-generation farm, where I grew up and farmed and still own some of the farmland. This photo is from the 1950s. So I have vivid memories of harvest time back in the 1950s. Low technology, hand labor. Some machines would lift the potatoes out of the ground, and then lots of workers would pick them by hand, put them in baskets, put them in bags. And unimaginable at that time was the technology that we have today on the farms, both electronic and biotechnology. Tractors that are smart enough to steer themselves. Plants that are smart, that have been genetically altered to protect themselves against pests. We've come such a long ways. But notice people in that slide. I'm going to talk about 3 things. One of them is human capital. Really, those are people, but that's a term that economists use for the people in the old days who worked hard. Now they're working smarter. So how smart are they? What's the measure of those people on the farm? But first, let's take a look at the numbers. This is a graph of the number of farms in the U.S. that grow potatoes. Every 4 to 5 years, the U.S. government estimates those, and you can do it for other crops as well. But notice, it's a downward trend, and a smart economist could just extend that line down until you get to that axis where there's the last person standing. And there are jokes about that. Who's going to be the last person standing? Of course, it's not going to come down to that, but the point is there are fewer of them, but they're changing. They're getting bigger. They're investing more in human capital. And as a result, we have a bimodal distribution of the size of those farms, measured by the number of hectares of potatoes that they grow. You have a bell-shaped curve, and then off to the right, you have those big ones who grow 400 plus hectares per farm. What do we know about them and their human capital and their efficiency that comes from that human capital? And who are they? Well, here's some of them. This is generation 1, 3, and 4 on this farming operation, Driscoll Farms. The first one who's in that portrait was Buzz Driscoll, who was a cowboy. And he had his ranch down on the bottomlands of the Snake River in eastern Idaho until the 1920s, when the government took it away from him. Built a dam and flooded the ranch, so he moved up on top of the hill and started a potato farm. And now they're into the 5th generation of that. And the operation is one of those off to the right, those big ones. And what are some of the characteristics? Well, there are 14 family members in there now, and they still recruit talent from outside that family. And they're organized into 9 corporations: farming, cowboys, trucks, truck repair, an auto dealership, fresh pack. Not a typical farm from the old measures, but now it is because of that human capital. And they farm between 11 and 12,000 hectares. And that young man who was in the previous slide went away to school and has a new position in the operation. He's the agronomy director. They used to rely on advice regarding crop production from a number of sources: universities, fertilizer dealers, chemical dealers, Simplot buying as a processor. And they figured they had to invest human capital into having one of their own go off to school, get a graduate degree in potato science to come back to the farm. Here's another one. A friend of mine who is a horticulture professor at the University of Wisconsin, who switched careers. He took a one-year leave of absence, a sabbatical leave, to go work with RPE Farms, a big operation that grows potatoes and sweet corn, peas, and beans, and he liked it so much. He quit, resigned from his professor position to be a farmer, to be at that cutting edge, not of the research, but of the application of that technology. Another example of enhanced human capital in potato and vegetable farms. This is one of my favorite students who I had in class about a quarter of a century ago. He's one of Idaho's biggest farmers. Not in terms of hectares, in terms of body weight. He's about 6'8" tall, a basketball champion, and he weighs about 140 kilograms, plus or minus 1 or 2 kilograms, depending on what he had for breakfast, I guess. He's a big guy. But what I admire about him is his passion for technology, his passion for his industry. And the passion track he's been on in recent years is robotics. I understand the importance of robotics. I'm not an expert about it, but I understand the economic importance, the efficiency importance. I was fascinated by what Dr. Kustra was talking about earlier. But I'm a simple guy. I had to go back to the dictionary to refresh my memory what robotics and robots were. Two different terms. One leads to the other. The first one is the branch of technology that deals with application of robots. And robots are those things that can be controlled by a human or by a computer, a smart machine, a robot. Interesting. Those self-steering tractors. I did some research about robots in Australia and found out that there's research and development on machines that help in horticulture production. And on the livestock stations, you can have cowboys that you don't have to feed beans to. They're just robots tending the cattle. Amazing. And there's this machine called a Prospero in the research phase, coming to development probably soon. But it's this machine with multiple legs that walks slowly across the field. The speed doesn't matter because you can send out hundreds of them to cover that field. And they walk and they see if there's a gap where a plant should be, put in a seed, maybe planted a bit late, identify weeds and destroy them, and a swarm of robots out in the field. Hard to imagine, but some people think it's coming. And the robots in the air. My former student, I admire him because he takes leadership roles in grower organizations. He was a speaker in Australia at the Society of Precision Agriculture in Australia. And he's a drone expert now. Those robots in the air. He says he uses it for his own farm and sells the technology to other farmers. But that field's not a circle. It's not center pivot irrigated. This is a dry land field that he has, in which he grows grains and pulses, peas and lentils. And he said the drone gives a big picture, a whole picture for precision agriculture. Instead of scattered soil samples and tissue tests, he said you can see more from the air. And you can look at plant population density, fix the problem this year or next year. If the crop needs more nitrogen, you get a whole picture from the air for that precision technology. The third thing I'm going to talk about is biotechnology, what I call green GM. I've worked for these different entities. I've been on their payroll while as a professor and now as a retired professor. Simplot at the top left in Michigan State University, the other corner, still working for them. But the first one I went to work for is down the lower right, Calgene, in the late 1980s. I was hired to look at the value of different traits for different crops, including potatoes and tomatoes. And I just said that wrong, didn't I? I got potatoes right. How do you say tomato? That's tomato. Okay, thank you. So the first product, plant product, to go on the market in the U.S. that was GM was a tomato, developed by Calgene, and it had a longer shelf life. Didn't have to be picked green, could be picked ripe. It could stay on the supermarket shelf for a longer time. It was the Flavor Savor tomato. And Calgene has since been bought out by Monsanto. But I believe in this technology. But I've been involved from the beginning in the business aspect of it, not the scientific aspect. So I told you I'm a simple guy, and simple-minded people like me sometimes put colors to technology. And my colleagues at Simplot said, well, maybe that's too simple. You should be more scientific. But I use red and green. And colors connotate different things. When you see a flashing red light, what do? You stop your vehicle. Stop signs are red. Red can mean caution, stop, danger. And what does green mean? Well, that's a friendly color everybody loves. Nature's green. In fact, they even call people who love nature greenies or greens. So red technology, as I see it, is a transfer of genetic material from one species to another. And that's much of what we've had. Bt, a soil bacterium, contributed DNA into biotech, insect-protected plants. Green means you may use some of the same technology, but you stay within that family. Potatoes are Solanaceae. Tomatoes, peppers, potatoes. You don't take genes from somewhere else. And it's viewed differently by the public. We've done some consumer research, and here I've substituted innate technology for green, GMO for red, and they view two of those about the same, traditional breeding and green GM. And red GM is a bit below that. So you can get your foot in the door with green, and red might follow later. But the train has left the station. This is a graph of GM hectares in both rich and poor countries, and they're steadily increasing. The train has left the station. In North America, we have crops that are 90+% GM. Sugar beets happened rapidly. It went from 0 one year to 50% the next year to 90% the second year. So when the conditions are right and the product works, adaptation can be rapid. A couple of vegetable products, sweet corn, BT, Roundup Ready, field corn and sweet corn, but GM sweet corn is all over the market in the U.S. Walmart carries it. It was approved by Walmart a couple years ago. And there's a virus-resistant squash. And more products to come. And what about potatoes? Well, how many of you have heard of acrylamide? A couple. Acrylamide is a substance that Swedish scientists discovered about 15 years ago that occurs in foods and beverages when cooked at high temperatures. Often it's associated with the browning or blackening. Acrylamide has been found to cause cancer in rats, along with other products, and deformed offspring. So acrylamide 15 years ago was seen as a scary thing to the French fry industry. Fries were high on that list about carrying acrylamide. So Simplot invested in the science of developing low acrylamide potatoes, and we're successful with green GM technology. Only using genetic material from wild and cultivated potatoes to develop new traits, better potatoes for existing public varieties. And the traits for those Simplot innate potatoes are first, low acrylamide. Second, non-browning. You peel them, they don't turn color. You cut them, they don't turn color. You drop them on a hard surface, cut them open, they don't show bruise. And we did some consumer focus group interviews where we were collecting information about consumers regarding fresh potatoes. And some of them would say, this is before we even brought up the innate potatoes, that sometimes they feel cheated and disgusted when they peel potatoes, cut them open, and see discoloring, see those internal black spots. And some of them said, we are reluctant to buy potatoes after we have an experience like that. So we think that the Simplot potato will help boost some consumer demand among those who would no longer be disgusted or cheated. So the white russet potatoes, that's the brand of these innate potatoes, on the fresh market, have been there for 2 years in a small way, in about 900 stores. And at first, like supermarkets anywhere, you have to pay to get your product on the shelf. And we did. But we're thinking in the future, we might get a premium for these potatoes. 5 different market channels. Simplot is not in the top one in frozen, which seems a bit ironic. This is a company that was built on frozen French fries, going mostly to McDonald's at first. Not there. Customers aren't ready yet. At the bottom, the D-high, not there. Not ready yet. Simplot makes D-high potatoes too. But those 3 in the middle, the fresh cut, and snacks are there. We see some potential in the fresh cut market to build a market where it's been nearly non-existent before. We look into opportunities in fresh cut, like the fresh cut baby carrots, that increase total carrot demand and consumption dramatically. We'd like to be there in the refrigerated shelf with them, with fresh cut potatoes. So we looked at some price information. We looked at retail supermarket prices of the whole item. This graph is for fruit. A whole apple versus a sliced apple. So that sliced apple would bring a price on this graph of a little more than twice the whole apple. The number is a little more than 2. Watermelon's almost 10 to 1. An economic opportunity. We looked at vegetables too. Broccoli, carrots, the onions. So when most people peel an onion or cut an onion, they tear up. So the message is consumers are willing to pay somebody else to cry for them. 9 to 1, 8 to 1. So we figured about 4 to 1. If we could enter this market with a price 4 times the price of whole potatoes, we see that as an economic opportunity. So there is a fresh cut industry, and to keep the cut and peeled potatoes from browning, they use a chemical that has to carry a warning label. You can see in that circle, it says, do not eat raw. How tough is it to sell a product that has a label that says, do not eat? Well, we see the Simplot innate potato is not having that burden. You don't have to say, do not eat. A shelf life of a couple of weeks, and the convenience. No preservatives, washing, peeling, cutting. Let somebody else do that. We are selling to restaurants right now in the Las Vegas casinos. That's our first foot in the door. There's increasing demand for sustainability. So the target of some government and non-government groups is we need to reduce food waste. We grow it, we transport it, and not all of it is eaten. So some research has shown that carrots, for example, at the retail level, waste about 5%. They're not purchased. They get too ugly, too old. 19% wasted at home. Onions, The total's around 40%. Potatoes, 7% plus 28%. So there's a saying in the market that a big share of the market is that waste bin. We know consumers and the whole chain throw away some produce. And don't mess with that. Some of our product goes there. It helps support our prices. But offsetting that is government and non-government organizations saying we have to stop that waste. So Simplot customers want to have information about how much waste can be saved. And we did some calculations regarding bruising. We are in communication with non-government organizations who are big into sustainability. The World Wildlife Fund, that panda, that symbol, that logo that many people recognize around the world, has already got a Simplot connection. Simplot owns John West, the seafood company in Australia. They have an alliance with WWF and use of that logo on their product. We're thinking that might happen with innate potatoes as well. We're in contact with the Nature Conservancy, and they're cooperating with some research projects, and maybe we'll get some blessing. You can't call it a blessing. Approval from some NGOs. Greenpeace, that would be a ways off, but maybe someday. So we have some assumptions we found about how much water it takes to produce a ton of potatoes, and it's 142,000 liters. Wow. And some people, some entities are concerned about water and CO2, and we have the numbers, and we've cranked them out, and did some estimates of what innate would save, and water use. If some of that waste can be eliminated in the potato marketing chain, you could reduce water use by 76 billion. That's B, not M. Billion liters. It's fun to talk about numbers that big. Billions. So that's part of the sustainability effort. We looked at economics too and saw big savings by reducing waste from bruise and blight and storage. And at the individual grower level, we have some estimates that operating cost of production for conventional russet Burbanks, about $105 a ton. Just the operating cost, not the fixed cost of land rent or ownership, or depreciation, and owner salaries and things like that. Just the cash costs of fuel, fertilizer, seed, and that type of thing. And that innate could reduce it by $30, 28%. And part of the yield, marketable yield impact of that is the blight, bruise, storage traits, and a switch in variety from russet Burbank to Ranger russet. Rangers bruise easily, but we've transformed that one too. Now it no longer bruises easily, and it has a higher yield. With some growers shift from russet Burbank to Ranger, you get that benefit. On the revenue side, we see higher yields that I just discussed. Improved pack out, less storage loss, and price premiums. So I talked about these three things, just a recap a bit. I talked about some of the growers and their investment in human capital. And two of those growers that I showed earlier are now innate growers. Robotics, fascinating. And you're going to hear more from other speakers today about that. But robotics are going to be more important from seed and tissue culture to production in the field and in the greenhouses, and even at the quick service restaurants, the QSRs, where you go through the drive-thru and a robot takes your order and hands the items to you. Far-fetched? It's happening now in Arizona and the US. Robots in the drive-in line. And the third topic was green GM. So we have someone else joining this green GM thing in the US. The most popular vegetable in the US is the potato. The most popular fruit in the US is the apple. There's a green GM apple that has been approved, developed by a company in British Columbia, Canada, Okanagan Specialty Fruits. Has that same non-browning property. You cut the apple, it doesn't turn brown. And maybe in the future, this green GM technology will be extended to other vegetable crops that turn brown when you cut them. One more item in the wrap-up. The USDA has a public comment period. Before they approve a GM product, anybody in the public can get on the computer and send a message, and we count negative and positive comments. And salmon is the one on the left that goes up steeply. 1.3 million negative comments, because that product has a heartbeat. There's that heartbeat issue. People see GM plants as more acceptable than animals. And the one on the bottom, under the radar, is the innate potato. The activists don't care as much about that partly because of the technology, the green GM technology. So as I understand it, this is time for panel questions. And thank you very much.